Welcome to Utah State University's Vertebrate Paleontology course. My name is Benjamin Berger. In this video, we will evaluate the evidence for the three major theories for the extinction of the ice-aged mammals. Now, if you have a time machine and you traveled just a tiny fraction of a geological second into the past, just 25,000 years or 0.025 million years into the past, the world would have been much different than it is today. Humans were around, but they were living in small bands or tribes, living across Africa, Europe, Asia, some Pacific islands, and even in Australia. However, we as a species had yet to arrive in the Americas. In the absence of humans, North America and South America were a cornucopia of large, iconic mammals like mastodons and mammoths, glyptodons, giant ground sloths, giant beavers, tapirs, horses, camels, muskox, and large bison herds, the last group to have recently arrived, immigrating in to North America from Europe. But starting around 13,000 to 12,000 years ago, groups of humans began crossing over from Asia across the Bering Strait, and they may have not been the first, as there is some evidence of Pacific Islanders discovering South America and living along the coast of Chile with radiometric dates from an interesting site called Monteverna that dates to 14,000 years ago. Now, this early colony would have been the first permanent occupation of the New World, and the people that lived there likely hunted and fished along the edge of a new unexplored world. Over the course of the next several thousand years, from 14,000 to 10,000 years ago, a mass extinction occurred across the American continents. Victims included the mastodons and mammoths, but also many large iconic mammals like toxodons and glyptodons and giant ground sloths and saber-toothed cats and other mammals, all of which tended to be larger than dog size. Something was killing the megafauna. There are three theories that have been proposed as to the cause of the late Pleistocene megafauna extinctions. The first is what is called the Overkill Hypothesis, which contends that it was the humans and they just overhunted and wiped off all of the large mammals from the Americas. The second is what is called the Impact Hypothesis, which contends that the extinction happened after a massive impact of a meteorite, sometime during this time around 12,000 years ago. The third theory is what is called the Climate Hypothesis, which contends that the extinction was a result of the changing climate as we came out of the last ice age between 25,000 to 10,000 years ago. These three hypotheses are called the Overkill, Impact, and Climate hypotheses. So what evidence is there for any of these ideas? And is one hypothesis better supported by the facts accumulated over the years by inquiring scientists? Let's first look at the more flashy hypothesis, the impact hypothesis. Is there any evidence for a meteorite impact around the late Pleistocene? This theory is likely the most controversial, and as such, it's often featured in television documentaries on the Ice Age extinctions. The idea first came about from the observation of thin charcoal layers that were found throughout the late Pleistocene units in North America and Europe, many of which were dated to around 12,900 years ago, and within this band of time representing the extinction. Several authors advocate that the charcoal layers represent a single event, and it was a massive impact of a meteorite. The major problem with this theory was that there was no impact crater. The large meteorite crater near Flagstaff, Arizona dates to around 50,000 years ago, much too old for the megafauna extinction event, and much too small for the level of extinction that we see. If a large meteorite impact occurred just 12,900 years ago, there would have been a crater preserved, or at least evidence for one somewhere on the planet, and none have been found. The promoters of this theory suggested that the crater might have crashed into the large ice sheets that covered North America and melted since then, in a sense erasing the record of the impact. Yet, radiometric dates for the last surviving mammoths place the last herd living on the Wrangel Island up to around 6,000 years ago, right near where the proposed impact took place. Yet, South American megafaunas disappeared much earlier, near 11,000 years ago. So if an impact occurred, it must have had a global reach to South America as well, and avoided these faunas in the northern latitudes. It was not looking good for the theory until nanodiamonds were reported from the layers of charcoal that were believed to have been the result of an impact. Now, it's important to note that uridium, that was used to identify the KT impact hypothesis, was oddly absent. Nanodiamonds are small crystalline carbon which is thought to be formed during the high pressure and temperature of meteorite impacts. However, only one study could find them, and repeated sampling has revealed no other sites with nanodiamonds. No shock quartz has been confirmed to this time period, further putting doubt on the impact hypothesis. In fact, the impact hypothesis lives on only in a handful of scientists, but for most researchers, this hypothesis has dropped out of favor. For the next hypothesis, climate. Climate change, and especially global warming, has been a major topic. How it relates to the extinction of the Pleistocene megafauna has become a more popular idea among a large group of scientists in recent years. Now, because the event is so recent, we have a well-documented record of climate, particularly from ice core data. Based on ice core data, during the last 400,000 years, the Earth has been subjected to 4 major ice ages. The last one ended during the period of mass extinction between 25,000 years ago, the maximum cool down, and 10,000 years ago, although the warming has increased substantially since then. This last 10,000 years of Earth is referred to as the Holocene and ushers in the age of humans, and formal written records extend to this age. The climate shift from the last ice age to a warming period was kind of a jagged, weird shift, with this unusual reversal in warming between 12,900 to 11,700 years ago, particularly in the ice core data from Greenland. This period of time is referred to as the Young Dryas. It's named after a genus of alpine tundra wildflowers that grow. Now, the pollen of this wildflower is found during this interval in many Scandinavian lakes. The reversal meant that during the major warm-up, as we came out of the last ice age, there was a shorter interval of a 2 to 5 degree drop in temperatures. But the event was pretty limited to the northern Atlantic, and it's believed to be the result of fresh water from melting ice sheets entering into the northern Atlantic, and this resulted in a slowdown of the thermohaline circulation system of deep water circulation, and preventing warm equatorial water to warm the northern Atlantic land masses, especially in Western Europe during this period of time. So this cool down does not seem to have had much of a big factor in places like South America and along the Pacific coast of North America. Yet, we saw major extinctions during this period of time in those geographic regions. The overall climate mostly shows a gradual warming during this period, but there's been previous warming events in the Pleistocene, and these events, while really dramatic, did not impact the small mammal faunas that were living at the time. So if climate was a factor, then why don't we see smaller mammal species also on the list of extinct animals through the event? Most survived without much change. Large mammals like mastodons and mammoths can move to new habitats and new climates if they're not ideal. Smaller, more specialized mammals, particularly tied to a narrow range of a particular species of tree or type of plant, would be more susceptible to climate. But we don't see their extinction. It's the big mammals, and really only the large mammals, that go extinct. Climate advocates have been trying to find evidence of extinction of small mammals, in particular those that might be tied to vegetation changes. And there's been too few examples of small mammal extinctions that coincide with the megafauna extinctions. Now this is very different than, for example, the Paleocene-Eocene boundary, which was an extinction event that had a major impact on small mammals and coincides with this massive global warming event. While climate change can invoke and cause mass extinction, the late Pleistocene was not a big enough swing to drive large mammals to extinction. Plus, the closest living relatives of mastodons and mammoths are elephants, which live in warm environments. Climate advocates are not necessarily specific about which change. Was it the young Dryas event or the general warming of the interglacial that was the particular cause of the extinction? So climate is not as well supported as the sole cause of the megafauna extinction, which leaves the cause of the extinction falling on humans with the overkill hypothesis. The overkill hypothesis was first laid critically out in the 1960s with the meticulous work of Paul Martin. In 1989, he and Richard Klein edited a book entitled Quaternary Extinctions, a Prehistoric Revolution, in which scientists documented the radiometric ages of human occupation of a region with the local timing of the megafauna extinctions. The resulting ages supported the idea that humans hunted the large mammals to extinction as they increased their populations. This is why we only see the extinction of large mammals to the exclusion of smaller mammals. The development of a new tool that would result in greater hunting abilities for these early Americans may explain the effectiveness of humans in killing large mammals during this period of time. The mass extinctions in North America and South America were tied closely to the appearance of what has been called the Clovis point. This is a fluted, narrow spearhead which tipped the end of a wooden spear. These sharp tools allowed bands of humans to bring down larger prey. The idea of overkill has more recently been supported by some amazing archaeological sites. A recent discovery was made in Boulder, Colorado, near the base of Flagstaff Mountain, which helps to pinpoint what animals the Clovis point was used on. While landscaping his yard, a local resident discovered a cache of 82 artifacts, including 11 Clovis points in 2006. These points were analyzed and discovered to contain the protein of sheep, bear, horse, and camel. Now, both horses and camels were mammals that would go extinct. And here was evidence of humans hunting and killing two of the animals that would go extinct, horses and camels in North America. Evidence from archaeological sites in Ohio of giant ground sloths show butcher marks on the femur with a radiometric age of 11,740 years before present. And other sites of giant ground sloths showing evidence of butchery and blackened bones from cooking have been found in South America. Critics of the overkill hypothesis have argued that humans using stone tools could not have killed every individual of these large mammals. Surely there were too few people, and they only killed the animals they needed for their own survival. And the extinction was very sudden. Now, while we have examples of humans killing, butchering, and eating these large mammals, it did not necessarily mean that they were the cause of the extinctions. But the extinction was, in fact, a little gradual, between 4,000 to 700 years. And as such, each generation of people then would have witnessed a very small incremental decrease in the total number of individuals of creatures like mastodons and giant ground sloths and glyptodons and toxodons and horses and camels. These large mammals were much easier to hunt than the quick pronghorn or the cliff-dwelling bighorn sheep or the very nimble deer that lived in the forests. And also, killing a really large mammal, it would feed your family for weeks. If these early humans lived just 30 years on average, the number of generations would have been 133 to 25 generations. Now, modeling this out over the period of time shows that humans were very capable to drive these species to extinction. Now, imagine what 100 generations in the future, what the world will look like. Could we keep alive those species today that are on the brink of extinction, alive over such a long span of time? Because we only live one lifespan, we don't see the general decline and change because we only see a single frame in a movie being played out over thousands and millions of years. If we just concerned with our own life and maybe our children's life, then what about 50 generations from now? I think the strongest evidence for the overkill hypothesis comes from the timing of megafauna extinctions on other continents. In Australia, around 50,000 years ago, there's a major extinction which predates the extinction in the Americas, but does coincide with the arrival of humans. In Madagascar, giant lemurs the size of gorillas and elephant birds and hippos died out only 900 years ago, shortly after the arrival of humans. Hence, the megafauna extinctions of large animals appear to coincide with the occupation of a region by us, by humans. It's really hard to come to the realization that humans were the cause of the major extinction and that our ancestors hunted and killed these giant mammals until they were completely erased from the world. While we can point toward external forces at play, meteorites and climate, the truth is that humans are an integral part of the planet, and that as a species, we may not be able to change the course of our inevitable destruction over the next several thousand years forward. Now, many biologists and ecologists have advocated for a new age, the Anthropocene, starting in the last century and defined by the impact of humans on the world's rock record. But I don't think a new term is necessary. The Holocene was also a period where the impact of humans was already felt on the planet, starting 9,700 years ago. We live in a world now depleted of its iconic megafauna, and not since the extinction of the dinosaurs have we seen such levels of extinction. Now, it's important to note that the Bronze Age, with the invention of metallurgy, began about 5,300 years ago. And the first dynasty of the Egyptian pharaohs began around 5,100 years ago. The last mammoths lived on isolated islands dated from about 7,900 to 6,000 years ago. Now, these isolated populations likely died out before the pyramids were constructed in Egypt. In summary, be sure to evaluate the evidence for the three major theories for the extinction of the Ice Age mammals. Thank you for watching. If you'd like to learn more about the Utah State University Geology program, check out the website geology.usu.edu or my own website benjamin-berger.org. Links are found in the description below.